consecutive overrides. Now we come to setting several consecutive alarms. Depending on the application, it may be necessary to define several alarm cases for the safety of a piece of operating equipment as described above, all of which must act independently of each other. In the case of an awning, for example, not only wind, but also moisture must be avoided under all circumstances. And temperature, in conjunction with moisture, can also play a role. Before you define the overrides to be used and the sequence in which they should be activated, you will normally have to consider all possible scenarios. For example, combinations of alarm conditions in order to avoid mistakes. In our case, however, it is quite simple, namely, when in all three alarm cases the retraction of the awning should take place. We then only have to activate two more overrides, one for the temperature and one for humidity or rain. The alarms already have the right names. Apart from the names, these three alarms are absolutely identical in their possibilities. The order of activation does not play a role, since all overrides work in the case like a logical OR gate. It is of course possible to define different response and release times, optimally adapted to the alarm times, which could still be important. Should the awning remain retracted after all alarms have been cancelled, or should it be extended again? The latter can be done by setting the behavior on deactivation parameter to the desired value. This can be the updated value, a certain position, or a move command. We are now at the end of this example. You are now able to define overrides, select them correctly, set them consecutively if necessary, and adjust the parameters accordingly. Next, we'll look at the options offered by the control value input in an override function.